Alright, so we're going to continue our discussion in equations here a little bit. First order equations. And first order mean the power on the variable is 1, which we don't see, but there is a 1 up here. So first, but I'll leave that off. And I'm going to start off with that equations are always conditional questions. They're always a true-false question. You know, x plus 4 equals 7. They want two things that are exactly the same or same value. And my question is, does 5 satisfy the equation? Well, one easy way to find out is to plug it in. 5 plus 4, replacing x with 5, gives me 9. Is 9 7? No, it's a false statement. So 5 doesn't satisfy the equation. And what we learned last time is we can find the value that does this. And guess and check is the easiest. I wrote that up here. I can just say, hey, I know 3 plus 4 is 7. But I want you to always think of an equal sign as a balance scale. These are exactly the same. And I had x plus 4. Well, how do I get rid of the plus 4? I take away 4 on each side. And if I take them away on the same side to keep the balance the same, I'm left with x and 3, or x equals 3. And again, this was a positive adding force, so the inverse operation of addition is subtraction. So I subtract 4 on each side. And I can do anything I want as long as I do it to both sides of an equation. So again, I want to do some quick review, and I'm going to do these awfully fast. You can pause the video and put these in your notebook and try them. And I'm going to go from quadrant 1 to 2 to 3 to 4. And I suppose where I put the numbers probably didn't matter. I'll put them down here. And when I do this, I always start by finding what operation. X plus negative 3, minus a minus 3, or plus 3 to get rid of a negative 3. And I get x equals 15. If I want to check, I simply put the value back in the equation and see what I get. And in my class, a check mark is a good thing. It means I checked it. And you can check every value as you go forward. Now, the next one you can't guess and check the value on. At least I can't. And I'll start by subtracting a fourth from both sides to get rid of plus a fourth. And I'm going to write this out. It's minus 3/8 plus a negative fourth, or minus 1/4. Well, what do I need to do? Add fractions. I need a common denominator, which I can see is 8. So I'll write negative 3/8 multiply by 2 and 2 minus 2/8 negative 3 plus negative 2, both to the left. So I get negative 5/8. And again, if I want to check that, I go back to the original problem and I simply plug it in. Negative 5/8 plus 1/4 is negative 3/8. And you check that out and it checks out. On the next one, I got a mixed number, 2 1/3 equals, plus k equals 2/9. Well, I don't care for mixed numbers, so I'm going to make it improper. The opposite operation of plus 7/3 is minus 7/3. And again, I don't have a like denominator, but this time I'm going to do it vertically. And I see 9 and 3, I know that that is going to be 3. And I'm going to get negative 21/9. 2 plus negative 21. 2 to the right, negative 21. How about negative 19/9? And again, if you want to check it, simply plug it in. Negative 19/9 plus 2 1/3 equals 2/9. And you work that out and it will check out. Now, the last one, a lot of times students get confused and they do the math too quickly. You've got to watch your signs and integers. What's the opposite operation of subtracting negative 27, or subtract 27? Add 27. I got to get to 0. They cancel, so I have k. Negative 38 to the left, 27, so I got to subtract them, and it's negative 11. And again, these are all first order equations. One-step equations. They all took one step to get to x equals. So, and they're all inverse operations. So again, how about 5x equals 20, or 5 times x equals 20? And I wrote guess and check is easy, because we know the answer is 4. What's happening between the 5 and the x? Well, that is a multiplication operation. What's the inverse of multiplication? Division. So I take 5x divided by 5 and 20 divided by 5. What I do to one side, I must do to the other. And again, fractions are division, division of fractions. 1x, or x, 20 divided by 5 is 4. And that's how we show it. And again, you think to yourself, why would you bother doing that work? Well, because there are problems we can't see the answers to. And I'll go right to examples here, starting up in quadrant 1 to 2 to 3 to 4. I have 7 times x equals 9. Well, the variable is being multiplied, so I need to do the opposite of multiplication, which is division. And that is 9/7. And again, if you want to check this, go to the original equation. 7 times 9/7 equals 9. Question mark. 9 equals 9. Boom. It checks out. You can check your answers every time. Again, I don't like mixed numbers, so I'll change it to improper. I can do anything I want as long as I do it to both sides. 9/4 times x. 2 ways to do this. One way, which I'm not going to work out, but I'm going to start that way, is we know it's multiplication. So I need to divide both sides by 9/4. But I also know that when I multiply, or when I divide a fraction, it's always multiplying reciprocal. And I look at this, I say, what is the reciprocal of 9/4? And it's 4/9. And I can multiply both sides by 4/9. When you make a number times its reciprocal, when you multiply a number by its reciprocal, you get 1. So I get 1x or x. And then 3 over 1 times 4 over 9, I get 3 times 4 all over 9, which I can reduce to 4/3. And again, if I take the time and I put it up in the problem, it will work out. Now, quadrant 3. What's happening here? I got x, fraction line 3. What is a fraction line? Division. What's the inverse of division? Multiplication. So I need to multiply both sides by 3. And when I do that, 3 over 1, right? But I don't need to show the over 1. 3's cancel. I get x equals 6. And again, you could tell probably from guess and check that 6 divided by 3 was 2. But again, it's important we see how to get there. And I can check by simply putting the value in. Now this is where students get confused. I hate mixed numbers, so I do this first. I go a equals a divided by 7/3 equals 4. A divided by 7/4. The inverse operation of division is multiplication. So I multiply by 7/3. I don't need the reciprocal here because I wasn't dividing, I was multiplying. And I get 28/3. Again, one-step operations. The previous ones we had to add or subtract. Here we had to multiply or divide. But again, one step to solving the problem. Anytime you see operations, you try to decide what makes it either 1 or 0. It takes a lot of practice. We'll keep working on it.